Good morning, students. Today we will see how to write vectors. If you are given its magnitude and direction, means figure. See, in last lecture we have discussed about unit vectors. Unit vector means a vector having magnitude unit is called unit vector, and unit vector indicates direction. For example, how to write any vector? You can write any vector as a product of its magnitude and unit vector. Magnitude, unit vector indicates direction. Okay, what is unit vector in positive x direction? I cap. In positive y direction, j cap, and in positive z direction, it is k cap. Respectively, in negative axis, it is minus I, minus j, and minus k. Clear about this? Okay, so now in this lecture we will see how to write, or if you are given figure, then how to write vectors. See, here it is. X, y, minus x and minus y. X's are given. Okay, now if I say it is one vector in this direction, like this, it is one vector. Okay, it is vector A. It is vector A. Clear about this? Okay, and let its length is 4 meter. Its length is 4 meter. Then how to represent, how to write this vector A? See, its length is 4 meter and it is in positive x direction. And it is in positive x direction. Then how to write vector? Vector A is equal to 4 I cap. It is 4 I cap. Clear about this? How to represent any vector? Any vector you have to represent as, you have to express as product of its magnitude and unit vector. Clear? Clear? Next, if I have another vector B in this direction, if I have another vector B in this direction, let its magnitude is 5. Let its magnitude is 5. Then how to represent this vector? See, B is equal to, how to represent this vector B? Its magnitude is 5. It is in positive y direction, so I can write as 5j. Clear about this? Okay, any vector is expressed as product of its magnitude and unit vector. Okay, if I have another vector C in this direction, C, let this distance is 3 meter. Let this distance is 3 meter. Then how to represent this vector C? Yes, how to represent this vector C? C is equal to, it is 3 minus I caret. Why minus I caret? Because it is in negative x direction. So I can write this as minus 3I caret. Minus 3I caret. Clear about this? So now if I draw another vector like this, if I draw another vector like this, it is vector D and it is 2. How to write this? Yes, D is equal to, it is minus 2j. It is minus 2j. Clear? So see, A, B, C, D, these 4 are vectors. But if I want to write their magnitudes only, then how to write? What is magnitude of A? It is 4. What is magnitude of B? It is 5. What is magnitude of C? It is 3. What is magnitude of D? It is 2. So clear about this, okay? Be clear about this. How to write vector and how to write their magnitude. Clear? Okay? Any problem? Now see, it is easy. When vectors are along x-axis, along y-axis, along z-axis, okay? To write vector it is easy. But if you are given a vector like this, see, for example, yes, it is one vector. It is one vector. Suppose take E, C, over, then let it is E. It is one vector E. It is one vector E. Then how to write this vector E? Then how to write this vector E? See, it is vector E. From head, draw a perpendicular on x-axis. Perpendicular means it makes angle 90. Clear about this? First of all, from head, draw a perpendicular on x-axis. Clear about this? Then it is called It is called its x component. It is called its x component. Means what is x component of E? 4 meter. Okay. Similarly, from this point, draw perpendicular on y-axis. Draw perpendicular on y-axis. Okay. Then yes, it is called y component of this vector. Or if simple, you are given these two coordinates 4, 5. You are given these two coordinates 4, 5. If you are given coordinates 4, 5, then how to write this vector E? You have to write vector E as 4i caret plus 5j caret. 4i caret plus 5j caret. Now you may ask the question, sir, how to write this? It is 4i plus 5j caret. Yes, it is easy to represent any vector along direction x, y, minus x and minus y. But how to represent any vector in a plane, in an xy plane? Okay, why we can indicate E is equal to 4i plus 5j? Yes, that is the question. So now we will see about this question. Okay, how to write any vector in terms of components, and that is our next theory. See, what is your next theory? Here it is. Resolution of vectors. What is meaning of resolution of vectors? Resolution of vectors, it means you can represent one vector as a combination of another vectors. Okay, you can represent one vector as combination of another vectors. For example, I have two non-zero vectors, small a and small b, in same plane with different direction, and another vector capital A in same plane, okay, but different direction. Okay, so totally I have three vectors, and I want to represent this vector A as combination of these two vectors. I want to represent this vector A as combination of these two vectors. Then how to represent? See, first of all, draw this vector A. First of all, draw this vector A with its direction and magnitude, okay? With its direction and magnitude, like this. Yes, it is vector A. Okay, it is vector A. It is its tail and it is its head. Clear about this? Clear about this? Okay, so it is vector A. Its head and its tail. Okay, now what you have to do? You have to multiply this vector A and B with some real numbers. Like I multiply vector A with lambda and I multiply vector B with mu. See, this lambda and mu, they are numbers, real numbers. Okay, so see what to do. If I multiply vector A with positive number lambda, you know that when a vector is multiplied with positive real number, its direction will remain same, but its magnitude changes by an amount which is multiplied. Okay, so here if I multiply this vector A, with lambda, direction of new vector, that is lambda A, will remain same. Okay, and draw this vector from tail of A. Then see how to draw. A multiply with lambda, so another vector which becomes, that is A lambda. Okay, here it is A lambda, or we can try it is lambda A, like this, in the same direction, but its magnitude changes. You have to draw this vector from tail of vector A. Now about vector B, see vector B is in this direction. Multiply this vector B with mu. Multiply with vector B with mu. Then yes, direction will remain same. And now you have to draw this vector from head of A. In the same direction. So if you draw this vector, that is mu B. Okay, see, direction is same. First vector you have to draw from tail of A. Second vector you have to draw from head of A with the respective directions. Then see, they will intersect at a point. They will intersect at a point. And see, from figure you can say a triangle is formed. A triangle is formed. So yes, you have to use vector addition with the help of triangle method. With the help of triangle method. How? See, you have to identify tail-head relation. See how? Suppose I am taking this path. It is tail. It is head. Again it is head. Means this path is wrong. Clear about this? Again, tail, head. It is head. So yes, that path is wrong. So I am taking reverse path. It is tail, head. It is tail and head. And you know that vectors having tail head relation, there is addition between them, and the remaining vector is the resultant vector. So here, with the help of triangle method, how can I write? I can write A is equal to lambda A caret plus mu B caret. Plus mu B caret. So yes, here I can represent vector A in terms of another two vectors. And see, A is equal to lambda A plus mu B. So lambda A is called component of vector A. Mu B is called component of vector A. These two are resolutions of vector A. Clear about this? So what is meaning of resolution of vector? Resolution of vector means you can write any vector as combination of another vectors. Here A is equal to lambda A plus mu B. Lambda A plus mu B. Clear about this? Lambda A and mu B, they are called components. Clear? Okay. Okay, you know what is resolution of vectors? Resolution of vector means you can represent a vector as addition of another vectors. But see, in the last theory, vector A is represented by lambda A and mu B. Lambda A and mu B, they are in different direction. They are not parallel to each other. They are not perpendicular to each other. Okay. Now, in this theory, yes, we will resolve vector. It is nothing but resolution of vector, but into perpendicular components. So what is theory title? See, perpendicular components of a vector, or you can also write resolution of vector in perpendicular components. Resolution of vector in perpendicular components. See, here it is. We can resolve a vector A in terms of component vectors that lie along x and y direction. Why x and y direction? You know that x and y axes are perpendicular to each other. So if we find components of a vector in direction of x and y, then yes, two components will be perpendicular to each other. Clear about this? Okay. See figure. Vector A lies in xy plane. X, y. And it is vector A. Clear about this? Now we will resolve this vector A into components. One component in x direction and one component in y direction. See how to resolve any vector in two components. Here I draw one figure, another figure. See, here it is. Suppose it is x-axis, it is y-axis, here it is origin, and I have one vector A like this, and I have one vector A like this. Clear about this? Okay. So see, now I want to resolve this vector A in two components. How to resolve this vector in two components? See carefully what is method. If I want to find component of A in direction of x, draw perpendiculars from tail and head of A on x-axis. How? See, it is tail. From tail of vector A, draw perpendicular on x-axis. Clear about this? Okay. Similarly, from head of vector A, draw perpendicular on x-axis. Perpendicular means it makes angle 90. Clear about this? So from vector A, from its tail and head, draw perpendiculars on x-axis. Then see this. It is called component of vector A in x direction. Clear about this? And I can write this as ax. Clear about this? Okay. Now how to find its y component? Similarly, from tail and head of vector, you have to draw perpendiculars on y-axis. Like this. From tail, perpendicular on y-axis. From head, perpendicular on y-axis. Okay, so yes, in this direction, it is y component of vector. Clear about this? How to take components of vector in any direction. You have to draw perpendiculars. Clear? It is called projection. Projection of A on x-axis, projection of A on y-axis. Clear about this? So this figure is for more information. Okay, now see again back to our original figure. Here it is. You are given xy plane vector A. See, it stays here. Hello, it is easy. It stays here. So projection of tail on x-axis and y-axis is same. You have to take all the projections from A. To find x component of this vector A, draw perpendicular on x-axis. It makes angle 90. Okay, so it is x component of vector, that is ax. It is x component of vector, that is ax. Clear about this? Okay. Similarly, draw perpendicular from head of vector A on y-axis. So it is y component of vector A, ay. Vector A, ax, x component, ay, y component. Clear about this? Now see, here. If I draw one vector in this direction, see, its direction is similar to ay. Its magnitude is similar to ay. So yes, I can say it is nothing but vector ay. Yes or no? I can say it is nothing but vector ay. Clear about this? Now see, one triangle is formed. Okay, let it is O, it is P, and it is Q. Then see in triangle OPQ. In triangle OPQ. What is relation? See, AX, it is tail, head, it is tail, it is head. So tail, head means there is addition of these two vectors, and this A is their resultant. So in triangle OPQ, from figure we can write A is equal to AX plus AY. A is equal to AX plus AY with the help of vector addition triangle method. Clear about this? AX plus AY is equal to A. AX plus AY is equal to A. So see, vector A is resolved into components AX and AY. AX in X direction, AY in Y direction, perpendicular components. Clear about this? Clear about this? Okay, now I can write this as A is equal to AXI caret plus AYJ caret plus AYJ caret. See, what is AX and AY? They are magnitude, means length. This length. Clear about this? Okay, if I draw another figure, see, it is X, it is Y. Let it is vector A, its magnitude is A. Its magnitude is AX and its magnitude is AY. Clear about this? Only magnitude. Hello. Only magnitude. It is in form of vectors. It is in form of magnitude. And let this angle is theta. Let this angle is theta. So here what is difference between AX? AX is vector. AY is vector. This AX is magnitude and it is direction. Magnitude and it is direction. Clear about this? Okay. Now how to find AX and AY? See from this figure. Let it is triangle OP and Q. So from triangle OPQ. In this triangle, first of all, take sine theta. What is sine theta? Sine theta is equal to, sine theta means opposite side upon hypotenuse. Theta, its opposite side is AY and its hypotenuse is A. So AY upon A. So therefore, if you make AY as subject, then AY is equal to, it is A sine theta. It is A sine theta. Similarly, if in the same triangle you take a cos theta, then cos theta is equal to adjacent side upon hypotenuse. See in figure, theta, its adjacent side is AX and its hypotenuse is A. So AX is equal to, it is A cos theta. It is A cos theta. Clear about this? So how to find value of AX? AX is equal to A cos theta and AY is equal to A sin theta. And yes, one important point that you have to remember about cos and sine. This vector A makes angle theta with x-axis. So component along x-axis is cos theta. Component along x-axis is A cos theta and another component is A sin theta. Clear about this? So yes, it is resolution of vector into perpendicular component. Again, if I want to write this vector A, then I can write A is equal to AXI plus AYJ. So A is equal to, it is A cos theta I plus A sin theta j. Plus A sin theta j. Clear about this? So it is how to represent any vector in terms of components. You have to remember this equation. A is equal to AXI plus AYJ, where what is AX? AX is equal to A cos theta. What is AY? AY is equal to A sin theta. For example, if you are given one vector like this, see carefully, okay? If you are given one vector like this, it is x-axis, it is y-axis, okay? It is origin. One vector is given in this direction, having value 10 meter, okay? And this angle is 60 degree, and this angle is 60 degree. Then how to resolve this vector C? I can write this vector C is equal to CXI plus CYJ, where what is CX? CX is equal to, it is C cos 60. It is C cos 60. What is value of C? It is sine. What is cos 60? It is 1 by 2. It is 1 by 2, so it is 5. Clear about this? Okay. What is its y component? Cy. It is C sin 60 is equal to, it is 10. Sin 60 means it is root 3 by 2. It is root 3 by 2 means it is 5 root 3. So how to represent this vector C? C is equal to, it is 5 I caret plus 5 root 3 j caret. Clear about this? Okay, so it is how to represent any vector in terms of components. Clear about this? Okay, so yes, it is one important theory of this chapter. Pause your video and write down for me.